Hi everyone. Hope you all will be doing good, I guess. Uh, this is one of our partnership with deeplearning.ai for Pie&AI event, Munich in Germany, and we are one of the ambassadors. Uh, let's wait for a few more minutes so that people will get into this. Okay, I guess it's good to go, I guess. Hi everyone, and this is Saravanan Jayachandran. First of all, welcome everyone, and thanks for joining us for the today's Pie&AI event. This is Saravanan Jayachandran, and I'm the co-founder of BitchCrunch. We are a data analytics firm, mainly focused on building data products and helping organizations to take data-oriented, business-driven decisions, operating mainly in India and Germany. Today is a big day for us. Uh, it's like adding one more feather in our hat, as we are the ambassadors for a Pie&AI event organized by deeplearning.ai, and we'll be representing them for the future events in Munich, Germany. Today, we're gonna host the webinar on the topic named "The Future of AI, Federated Learning." So, presented by none other than Mr. Vijay Pravin Maharajan. Uh, if you have any questions or any queries in the presentation, you can always type them in the chat box. So I'll bring them up in the at the end of the session. So now, without further ado, we'll turn the time over to the Vijay. And Vijay, thanks again for accepting our invitation to present this webinar. So to give a short introduction about Vijay, Vijay is a data storyteller, TEDx speaker. He is also awarded as 40 under 40 data scientist in India, and also he is a TUM alumni. So without wasting time, let's get started with the introduction video from our very own Andrew Wenji.
Hello, deep learners. I'm Andrew, founder of deeplearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the deeplearning.ai offices and meet some of the teams so we can see where it all happens.
Oh, hi, Edward.
Do you want to tell our friends at Pie&AI what you do at deeplearning.ai?
Sure. Hi. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having. Today, I'm putting together the next issue of Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on the Batch?
How much is going on this week? There is never a dull. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together.
All right, I know you're really busy, so let's you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pie&AI what you're working on?
Yes, sure. I'm leading a project with Workera, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
The AI field is new. Organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
That's really important work. Well, it's nice chatting. And now let's go chat to Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pie&AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in deeplearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, also.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project. Or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pie&AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot, both from the talks and from each other. And once again, welcome to the deeplearning.ai community.
So that's our introduction welcoming video from our Andrew NG. And without wasting much time, I would like to add Vijay Pravin to the stream. And Vijay, once again, thanks for accepting this webinar, and the session is yours now. Over to you, Vijay.
Hello guys. So thanks a lot, Saravanan and the team from BitScrunch, and thanks a lot deeplearning.ai and my idol Andrew NG. So am I audible, guys? So is it clear? How is it? And I guess Saravanan, the layout, we need to work on the layout. So just giving people some time to settle in. Yes, perfect. So I'm really excited about today. Just a second. Layout. Yeah. So I guess we need to have a change in layout, right? So what do you guys see on the screen on YouTube? Do you see a split screen, or do you just see myself alone? Hello, split screen. Okay, just give me a second. Yeah. So yes, myself. So yes, in the meantime, technical team is working on that. So thanks a lot for your time. I mean, it's close to 100 people waiting for the session, which is really great. So I would like to thank deeplearning.ai and the team as shown in the video. So Alice from the team, and greats like Andrew NG. I'll be having probably a call, fingers crossed, with him in the coming days. And yeah, so they were looking for ambassadors in Munich. So that's when BitsCrunch approached them, and they just invited me for their very first session with Pie&AI and deep learning. So I'm really excited as you guys. So thanks a lot for joining in. So it's 6:30 in India, and it is after lunch, post lunch session in Germany here. So about myself, as Saravanan said, I'll just quickly walk through who I am and what I'm doing here in Germany. So I'm Vijay Pravin Maharajan. I come from Tirunelveli, which is a place in Tamil Nadu, India. And I came to Germany for my masters, and I have been giving a lot of talks of late, especially during this COVID times. I've been giving a lot of lectures about video, data visualization, data science, and career guidance as well. But this is something out of the box. So I just wanted to flip the coin, and I just wanted to see the other side of the data science aspect. So that's why I challenged myself, and some of you might have heard about deep learning and AI, and also this Pie&AI event. So the level of expectations are pretty high, pretty much high. So that's the reason why I opted for this particular topic, which seems to be kind of very interesting for me, and at the same time, it's kind of an interesting aspect of data that we all need to know. So let me share my screen. Yeah, just a second. Yep. So today we're going to discuss the topic future of AI, federated learning. So till this point, I have been giving a lot of lectures on data visualization, and data science, as I already told. But for Pie&AI, I wanted to make it special, so that's why I came up with a different topic. So thanks again for those guys who worked alongside me to frame the slides and the design. The design is from deeplearning.ai. Again, thanks for them. And yes, so yeah. So again, thanks for BitsCrunch as well. I mean, they were the ones who invited me for this interesting session, and yeah, this could mark an interesting gate in my professional career as well. I'm looking forward to the coming days. It's going to be really interesting. So what is the agenda for today? So let's have some sort of introduction about what is this federated learning, what is the so-called FL, and let's just look into some history of it, who are the drivers of this federated learning, and I'll give you a couple of real world use cases, and then we brush up a little bit of basics, where we see what is differential privacy and data anonymization, and then we move on to why data anonymization isn't strong enough. So why what's the case? And then we have a little hands-on session as well, so where I'll be walking through a code snippet where we have a toy example with Bob and Alice. And in the meantime, if you have any queries, if you have any doubts, please do drop a text on the YouTube chat box, so that the guys from the technical team, they can bring in those questions to me, and I'll be happy to answer it. So just a second. And just a small sort of a disclaimer. So for those who are completely new to data privacy and machine learning, for you it could be a little difficult for you to, I mean, follow. But I mean, we have made it as simple as it, so that don't worry. And maybe the hands-on session could be something that you need some support. But otherwise, for people from data space, data science, and machine learning and artificial intelligence community, for you guys, this will be interesting, and I assure that you will have some key takeaways at the end of the day. So yes, before we start, just let me, yeah, okay. So let's just look into the different kind of approaches between the standard machine learning approach and the federated learning. So once you know that main difference, then it's easy for you to deep dive into the topic. So the standard machine learning approaches, what it does is it trains the model in a data center, or it takes it to the cloud and it processes it. But that doesn't happen in a federated learning. So in a standard machine learning approach, the users tend to give away their privacy, their data. So let's say a mobile device or any edge device, a user is prone to give away his privacy. So let's say age, demographic information, sex, and address, or what sort of informations. So that's the so to say, I mean, they give that kind of privacy in order to obtain a standard model, standard machine learning approach. But in federated learning, this is not going to happen. So what it does is a distributed learning approach. So the model is being sent to individuals in the sense it is being sent to each edge devices, let's say mobile phones in your hand, or cars that is running on the roads, automobiles and whatnot. So it is being distributed. So what happens is, instead of the processing that happens in a cloud or a data center, it happens locally. So it happens locally in some sort of ideal times. So whenever there is a sleep time, let's say around midnight, or sometime whenever there is a pause in a device usage, then it gets updated. So here the data privacy is kept intact, so the user doesn't lose the data privacy. So whatever he has on his hand or on his mobile phone is kept intact. It is not sent to any server, and there are a lot of data intrusion which is happening across the globe. And I mean, we recently saw what happened with Twitter. So there were a few guys who did some data breach, and they were earning some hefty bitcoins overnight. So that's the, I mean, that's how it is currently, and a lot of firms are actually working on the federated learning models and approaches. So I'll give you a couple of examples so that you will be able to follow. So so far so good. Are you able to follow? I mean, what's the difference between the standard machine learning approaches or federated learning? Can you able to grasp it, or do you want me to repeat anything? So I'll give you a minute or something so that you can drop in your texts. So in the meantime, I'll be also checking out YouTube, how is the space going on. Okay, so there are a couple of questions already. Thanks Vignesh, Babu, thanks a lot. Thanks guys. Okay, thanks Denika, good to go. Thanks Varun, thanks Amina Ferhati. Okay. Amina Ferhati, she didn't understand what is federated learning. Okay. So just repeating it again. So whatever machine learning models or approaches that are taking place. So it takes place primarily in a data center or in a cloud. So that's the traditional approach. So what you usually see, like a personalized recommendations or what sort of uh, prediction models. So it usually takes place in a cloud or in a data center. That is how big tech firms operate in an usual way. What federated learning does is it sends the model, it deploys the model onto each of us locally so that the models get distributed on, let's say, if you are using WhatsApp, if you are using your mobile phone, that particular application gets the model by itself, and then the machine learning happens locally. So how is your taste, what's your age, what's your preference, what's your taste. So that's how it does, and then it gives particular sets of results according to each and every individual's needs. So that's how federated learning is designed, and that is going to be the future. I mean, like, already half of the companies or some of the companies have deployed this federated learning, and it's fascinating, to be honest. So let's just go into the next slide. So I'll for those who still didn't understand this, I'll give you a real world use case. So let's say, since I work for Siemens, I'll share an example that I can totally relate to. So let's say if an autonomous driving vehicle is there, and I mean, not just autonomous driving vehicle, but whatever cars that can be able to send out data. So with currently the system is, the data has been sent to the central server or the cloud, where the data is being processed, and a lot of predictions are being made. I mean, like, the algorithms are processed centrally. But now with this federated learning, what happens is, a lot of autonomous driving cars, I don't want to mention the names of the firms, be it Volkswagen, Audi, BMW, you can name it. I mean, some of the top leaders in automobile divisions, what they are doing is, they are actually sending out the models to each and every of the every cars that are on the roads, and then the learning is being dealt in the car itself. So that again saves the user from sending his data, his own data, to the cloud, where there can be a data breach at any point of time. I mean, nobody is like a super wall where we cannot construct a concrete wall or something to protect data. That is the other side of the data business. So data, when it comes to data, privacy is always a thing that a lot of people have been trying to get hold of. Even if you look at Europe, Europe has implemented this GDPR, which is the General Data Protection Regulation, rules and regulations. So even with GDPR and so many stuffs in place, data privacy and data has always been a question in almost all the industries. So let's say I have been with Telefonica, I have been with Volkswagen for a small stint, and I've been with Siemens for 2 years, close to 2 years now, and it's always been a question mark whether we should use this data, or whether we can get rid of this data. So, considering that, now things are being deployed, distributed in a distributed manner, so that each and every one of us gets it locally and we process it. So, another real world use case is this Google Gboard, where we have it in Android. So, when a user specifically mentions what he wants to eat or where he wants to go, it learns by itself, by the preference of an individual. So let's say if somebody eats a lot of burgers, then it for sure suggests a place that is uh, somehow closely related or somehow closely located to him or her. So that's how machine learning is being done in terms of Gboard. Gboard is one of the coolest examples that we have currently in Android. So yes. So data anonymization. So some people might ask. I mean, some people have already asked in the chat box even before the video started. There were some guys who were asking about data anonymization and stuffs. Yes, we can do data anonymization. That is for sure. I mean, I work in a tech firm for the past 6-7 years, and we have been doing a lot of data anonymization over the years. But I'm still skeptical about this data anonymization techniques, because what happens is we never know what layers it crosses, who all get the access of these data. And it is also, on the other hand, uh, de-anonymization is also possible. So geeks can always de-anonymize any sets of data. So that's there. Uh, so there is a question. Saravanan, can you just bring in this question? So just a second.
Yes, sure. I have popped the
Mhm.
question as a video, I guess. I guess it should be visible to everyone. How to handle the training set and test set.
Okay, okay. So, I mean, it depends. So, how to handle the training and test data? I mean, if you look at the typical federated learning scenario, we have a lot of large population of potentially hundreds of millions of client devices, right? So, literally everybody is using a smartphone nowadays. And it is not just about a smartphone. As I said, it's all about the edge devices. So, the cars, the automobiles, the Fitbits that we have. So, whatever devices that are there. So, it is of millions of devices, so of which a small portion may be active, right? And it is active and available for training at any given moment. So as I said, an ideal time for any device is always there. I mean, we won't be driving a car 24/7, or we won't be using a mobile phone 24/7. So there will be this idle moment. So it depends. Some clients might have plugged in to the power source, and they are not on metered network. For instance, some use Wi-Fi, some use um, mobile internet. So generally the set of clients available to participate in a training, or let's say, or evaluation, is outside of developers control. So you can get hold of such devices only when they are offline, or when it is connected to internet, let's say. So that is how it is. And it is also impractical to coordinate all these devices. So forget about that. I mean, uh, you cannot coordinate millions of devices and you can train a model. So that's not how it works. So it works individually on equal sets of devices, and then it updates it to the center, so thereby reducing the privacy breach. So in the earlier case, what happened is a lot of data sets were sent along with the things that we wanted to do. But now we just restrict all the data, we just send the updated model to the server, and it gets updated, and it again comes back to us as an updated model. So that's how it happens. So the typical round is there. So it goes there, gets updated, and comes back to us as an updated model. And then we use it the next day. So that's how it is. So if we are looking at differential privacy, which is nothing but the mathematical I mean, version or the formula of privacy. So there are a couple of theories which derive this differential privacy. So there is this Delineus and Omnia guarantee. So I just don't want to bore a lot of people with hi-fi tech contents. So that's why I've just taken a couple of notes in between. And yes, so that was there with respect to privacy. They had a compelling uh, definition, but again, it was not conclusive. So again, there came Cynthia's definition of differential privacy. So where let's take an example where there are two groups of people, smokers and non-smokers. So what happens is, usually in a survey, if I log in as a smoker or a non-smoker, we give away the data, who is sending what, or who is a smoker or who is a non-smoker. And then the person who takes the survey, he knows, uh, by inference he knows, okay, whoever smokes has a high probability of getting a cancer, right? So whenever he sees some random person in the streets or on the roads, he might think of, okay, this person is more susceptible to getting a cancer. So that is what not going to happen with respect to differential privacy. I mean, here the user is totally, let's say, he will not be uh, known to the person who is taking the survey, and then ultimately he will not be taking any inferences, okay, which sets of people have joined in the survey, who is doing what, and this is totally uh, anonymized. But yeah, coming back to the point where people say we can also use data anonymization, we can anonymize certain sets of KPIs or parameters like demographics, age, and sex. But I feel it isn't strong enough. Why? The reason is Netflix announced a competition in 2006, if I'm not wrong. So what they did is they wanted to try out. They released a data set. They wanted to try out a personalized movie or web series recommendation for individual users. So what happened is, two guys from Texas, they did the de-anonymization. So they did uh, able to see who did what or who watched which series and movies. So this is why we call this data anonymization as not a bulletproof model. So there is always this chance of data getting leaked or de-anonymized, where a lot of users can get into trouble. So that's there. So I would say we'll, I mean, we are already 30 minutes into the session. I'll just quickly walk you through into the hands-on session so that you can relate it more and more, so that you see how it is done. So yes, just a second. Yep. Yeah. So that's the notebook, a collab, Google collab. So I'll just walk you through. So again, just to quickly summarize things. Before that, maybe I'll have a 1 minute break where I ask if there are any questions, or are you guys comfortable with the session so far? Are there any questions? Please do drop in your questions. So we'll see how it goes. Mhm. And yeah, there is also another interesting question. Can Saravanan, you can place the question on the video so that mhm, so that the viewers can watch it. Hello. Yeah.
Yeah, I have popped in the question, I guess.
Okay. Okay. Perfect. So there's a question whether federated learning uses LSTM or RNN for modeling. So it is actually not about LSTM or RNN architecture. So forget about what is being used. So federated learning is a machine learning approach for training the model locally. So it can be LSTM, it can be RNN, doesn't matter. So the main point here is we are doing the process locally and not on a central server. So that is what I have here. So instead of bringing training data to the model, which is a central server, you bring the model to the training data wherever it may be live. Let's say in a mobile device, in any edge device, in a car, in a Fitbit, in whatever devices that can be able to train it. So that is where this model is different from the traditional approach. So the data is not sent to a server. It is not sent anywhere. So usually the tech firms like Google, Microsoft, IBM, or whatnot, whatever companies you name it. So what they usually do is they take the data, they send it to the central server. So that's the normal approach. And with this kind of federated learning, it is not. So everything happens locally. Okay. Yeah. So we just like look into a small set of example where we'll see a toy federated learning example. So let's jump into it. So for those who are not sure about Google Colab, just just Google it. It's easy for you guys to jump into Colab, and you can also run some interesting models in there instead of installing or having some sophisticated systems locally. Yeah. So here, yeah, in this space here, I'm just importing some libraries that are necessary for this function. So I'll not be walking you through each and every line of the code, because I mean that is what not this session is about. This is just to give you an idea about how things or how federated learning is going to impact in the future. So for us, this sort of federated learning can be dealt with a couple of steps, but what we went with is this PySyft. So thanks for this OpenMined community here. So what we are using here is this PySyft. So if you ask whether this is the only way to deal with federated learning, definitely not. There are a number of ways where you can do this. So I'm just importing the PySyft library here, and since we have this Bob and Alice, I mean, we wanted to have it a fancy name, so we'll have Bob and Alice, let them be the remote workers. So let's say Bob might be someone running on your mobile phone, and Alice might be some remote worker that is running on somebody's mobile phone or any edge devices. It's not, again, not just about mobile devices or any device that can communicate with the other device. So let's put it as an edge device or something. And we have this hook, which is an extra functionality here to support the federated learning. And yeah, for guys who, let's say, want uh, to see how things roll or want to have this in your session after this live gets over, I'll make sure that Saravanan posts a link for this collab. I'll make sure that you can get an access for this set of code snippet. It is easily readily available as well, so it doesn't matter. I'll make sure that the technical team put this to you. So here we just initialize the data. I mean, it's nothing but to cross one matrix, where we also set the target, and the model, a toy model that we have taken here is a linear model. And in order to optimize it, we go with SGD. I mean, stochastic gradient descent optimizer. Doesn't mean that we should always go with this SGD. I mean, since it's a run through, it's a walkthrough, and it's for a simple understanding, we just go with this SGD. And what we do is we erase any previous gradients if there exists anything, and we then make a model. So what happens here is we make a prediction. I mean, prediction on the particular data, and then for sure we need to calculate the loss and figuring out what happened just to back trace. And yeah, so that's what happens here. I'll just quickly run through these. So if you see here, we have I forgot to say this. So we have 20 epoch, so 20 iterations. So if you look at the first one and the last one, so the loss is pretty much null when it comes to the 20th iteration. So, so that's that traditional approach. So the data is being sent to the server, and it operates there. So the data is being sent to the server, central server. But what happens with the toy dataset with Bob and Alice that we have initialized at the beginning? So again, since it's a simple use case, the data is pretty simple. I mean, it's just 0001 and 10 and 11. So what we do is, instead of going with a training data and test data in an ideal case, we just split it to Bob and Alice. That is much simpler, right? We just have two workers that can work locally on any device. So we say, let's say the first set of two data goes for Bob, like 00 and 01 goes to Bob, and we also set a target variable. And we are going to use the same model here again, where if you see here, it is being sent to Bob and Alice. So that's what the difference is. So instead of sending the model, instead of sending all the data to the centralized server, what happens here is it is being sent to the workers. So let's say Bob and Alice in our case, which is in your mobile phones or in others edge devices. So it is being sent to the target, which is Bob and Alice, and thereby we have almost the same here. So let's say we run an iteration of 20, which is what we did it before. And if you look at, uh, we can either use, yes, just a second, as it initialized. Yeah, so in the first case, we didn't make use of this Bob and Alice as we initialized here. We never used this in the first use case, but in the second one, we are sending that to the Bob and Alice. So what happens is everything is done locally. So it trains the model, and you can see is being done on a local machine, so on an edge device. So again, if you look at the loss for the 20 iterations, uh, I mean, it goes to the negative scale. So that's what it is. So the process is again simple. It is not something that is being run on a central server, but thereby it is being taken to your local devices, and thereby we preserve the privacy. We preserve the privacy of Bob and Alice and a lot more people. So what we do with this sort of model is we are not giving away any data from us. So that's the ultimate thing that we are doing. But again, here there are a couple of shortcomings as well. I mean, for sure, no model is without any shortcomings. So it's all about the advancements that happen in each and every field, right? So the shortcomings is again here. So here, if you look at the shortcomings, it is this particular sets of user data which is being transmitted, right? So it gets updated once in a while. So what happens is the central server can locate, okay, Vijay has sent this model, so he can have this set of parameters in his mobile phone. So he is interested into home appliances, or let's say he's interested into homes or furnitures or something. So they can backtrace. So that is again a little shortcoming, but for sure, if things are getting averaged, so let's say if the model is sent to the server, what can happen is we can average, we can make sure that Bob, Alice, and whatnot. So many people's models, local models, can be averaged and then sent to the server, so that this shortcoming can again be saved. So that is one thing. So yes, is there any question here? So let me just check YouTube. Okay. Mhm. Yeah, there is a nice question. Differences between federated learning and transfer learning. That's a good one. Saravanan, can we have that on screen so that people can see that on the screen?
Yes, sure. I have popped it on the screen.
Okay, perfect. So if you look at the differences between federated learning and transfer learning, for transfer learning, we use already pre-trained weights, right? We use pre-trained weights and again train on new data to train the model. So that's what happens with the transfer learning. So we use pre-trained weights and we again train on new data to train the model. But in federated learning, the model is sent to the device to update its weights. So this is something different. So again, you need to understand. So what happens with transfer learning is we use pre-trained weights, but here the model is sent to the device directly where it gets updated, and then it updates its weights to the central server. So that's the prime difference. Yeah. Any other questions? Mhm. There is another interesting question here. Training of model requires heavy hardwares. How to train on edge device? That's something that we should pop up on the screen. Training of model requires heavy hardware. So that's the common mindset that we all have. So I mean, it's not about training models needs heavy hardware all the time. So things are getting evolved. I mean, in few years from now, you won't be seeing a lot of. Just a second. Just a second. Yeah. So coming back to the question, sorry, there are too many questions out there. Got distracted. So the training of model requires heavy hardware, right? So your question is how to train a model on an edge device. So as I said, devices only participate when they're eligible. So when there is an idle time, let's say if a car is being parked in a garage, or if a mobile phone is being kept idle, so that is where a device is eligible. So we are not impacting our users or their phones at all. So it is not like we make use of your processor or your device's energy. Never. No firms do that thing. So what happens is, as I said, whenever the devices are available and eligible, things are being processed at the back end. So also the training will be very small embeds. So it's not like in huge gigabytes. So let's say you are searching for a restaurant, you are searching for something that you can, let's say, go out for dinner or go out for some fun. That is not in GBs, right? So, and particularly we are talking about one single application and not all the applications. So it is probably in megabits, maybe not definitely kilobytes, but for sure in megabytes. So the training will be, it can be done in few minutes. It won't take a lot of time, and it is not something that is in gigabytes where you need high-end hardwares and a lot of high-equipped data centers. It's never been the case. Yes, and there is one more question. Again, what are the changes we have to make in terms of training a machine learning model like random forest or anything that is using federated machine learning. To be honest, you don't have to do anything. You don't have to uh, change the model architecture for the device. So forget about where the process happens. So forget about the data center, forget about the cloud space where the tech firms do all these kinds of processing. And it is also not about your device, how capable my mobile is um, just has this processor. It might not be able to do that. Forget about all these constraints. So we don't have to change any architecture. So the model remains the same. It it is just sent remotely. It is just sent to the remote device for training. So you don't have to do any kind of fancy stuffs. It will update your model to the local device, which is not so fancily created. So yeah, that should be the answer. Yes. Mhm. And yeah, another question here. Thanks a lot. Thanks a lot, guys, for pouring in your questions, because that's what makes it more interesting, because we are here to ultimately learn. So for instance, I came across this particular topic in my recent times. I mean, it was not something that I have been working on and on. So I'm a data analytics expert who works or who focuses more on data visualization. So if you give something to me that needs business analytics or business intelligence, I'm the ready to go person. But these kind of stuffs, it's all new learning. So it's all about the learning. As I say it in my every other webinars, learning is the key. So please do keep on learning and improvise each day. So in this case, coming back to the question here, so a guy is asking if the model is sent to the device, can we extract the model? Definitely not. If federated learning is being deployed by companies like Google, they'll uh, not be I mean allowing the user to extract the models. So for sure, it cannot be extracted, and it is well encrypted, so that you cannot access either the models or the data as well. So what happens is some portion of the data is being taken for the processing, and as I said, that goes to the server, gets updated, and comes back as an updated model. So no change or nothing has to be done with respect to model and extraction. Extraction never, not at all possible. Yes. And there is another question here. A lot of questions. There is one question here. Can this lead to model biased to the device instead of learning from the data on the device? Can you pop up the question, Saravanan, on the screen? So can this lead to model bias to the device instead of learning from the data on the device? So we always, I mean, have two sets of approaches, right? We always think of learning from the data on the device, and it is also, in a way, you can think like it could be a model biased, but there is no point for bias here. That's the I mean, go to answer, I would say. There is no point for bias here, since the model will be trained based on the user's data. So it is you will be giving your preferences or your searches. So it is actually based on users data and personalized based on users search or preference. So let's say you want to go out for a dinner, then it is you searching for let's say a Greek restaurant or an Italian restaurant. So that is you searching for something. So it is, again, I mean, it is not there is no point of bias here. So it's not either a model biased or you cannot compare that with anything. I would say it's just making use of your own data, and that is what happens here. So yeah, that's what I had in this session. You can, I mean, keep your questions coming. I'm ready to answer here. we'll also make sure that we'll have another session, dedicated session, where we plan to build something with the federated learning, or I'll again come back to you with another interesting topic. So let's just learn something new. So as I said, again, repeating that again, learning is key. Keep doing it. I recently saw a post on LinkedIn that a guy who is 30, who has no coding background, is actually into a boot camp, data boot camp that I suggested, and he has come out with flying colors. So that is what I want you guys to do. So don't just restrict yourself from not exploring anything. So just try to build upon your various aspects, be versatile, and uh, please stay safe. And talking about LinkedIn, I mean, that's me on LinkedIn. If you wish, you can follow me. I mean, I have a 30,000 network there. Unfortunately, I cannot accept your invitation because LinkedIn has set a limit of 30K. But for sure, I can text you on some other platforms if you wish. If something is urgent, please do drop a personalized request to my profile so that I know who is who and what needs to be done. And if you don't get any reply from me on LinkedIn, please make sure that you try to reach me on any other profile. You can check out vijaypravin.com, where you see me on multiple platforms. I mean, I'm same everywhere. If you open Instagram, if you open Facebook, I'm Vijay Pravin Maharajan everywhere. So just log on there, just drop me a text, and then yeah, will be. And another question. Mhm. There is another question. Should we send model plus data set to edge devices to mix it with user data during learning on edge device? You- Only the model is sent to the edge device to train on the user's data. So you don't have to do anything. The model is being sent locally. So let's say you are using a device, I am using a device, a lot of people here using a device. So model is being sent to it is distributed. You can call it distribution of models. So it is being distributed, and then it works, as I said, on an ideal time whenever the devices is available and eligible. So you also need to make sure that the devices are eligible. Yep. So coming back to the sorry. Yeah. So any other questions? So yeah, thanks a lot for the fruitful and interactive 1 hour of session. This is something different for me as well. So I hope you had some key takeaways, and I wish to explore more into it. So yeah, I mean, for sure, some of you guys might have had a couple of key takeaways today. For sure, you need to work on it, and probably I'll go back home, take these questions, and as learning for me, there are much more I mean, way more interesting questions to me here today, because usually the data visualization and the other sessions are not so technically sound and interactive, but rather this session um, gave me something that is much needed. So that the viewers get educated and we learn something new, and with the help of you I learn something new. So in a way, it's mutually beneficial for both ends. So is there any other questions lined up, Saravanan, or should we wind up? So, yep. Yes, and there is someone asking, the slides, collab notebook, and video record of this event will be shared to the participants. It is available. I'll make sure that the technical team will put up the collab notebook on the description of this video later. And yes, you can always watch this YouTube video. It is live. It will be there on YouTube 24/7, so you can rewind, fast forward, and do wonders there. So that is this stuff. Yeah, thanks, Santosh. Santosh says it's really helpful to get a head start. We'll try to dive deep and learn more on this topic. Thumbs up from Vijay, thumbs up from the whole team. So that's the goal of this
Exactly.
topic. So we wanted to teach people some new stuffs rather than generically saying what is data science and what is data visualization and what is this and that. So instead, we wanted to deep dive into particulars. I hope we had a nice session today. And yeah, thanks. Neural programming with Yasho. I should check your
Yes.
name. And yes, Ismail, I'll drop the collab. We'll make sure that the collab notebook reaches all of you. So I'll posting it on the description. So yeah, thanks a lot, guys. Thanks for making it interactive. And thanks, Nandini. Thanks a lot. Thanks, Apperson, Johnson. Thanks a lot. In Tamil, you can say Nandri
Yeah.
Vanakkam.
Yeah. Thanks for the show, guys. It's really nice hosting you again, Vijay, and hope you guys have learned something new today. So with this, we are leaving as of now, and we have planned some another sessions where we'll be diving deep into the federated learning with some hands-on real-world applications of something similar to building some Android applications or some stuff like that. So just watch us and keep. I will be posting you. Yeah. Thank you
Yep.
so much once again, and thank you all. Thank you so much.
Yeah.
Yeah.
Thanks a lot, Saravanan. Thanks a lot. Thanks again for hosting me on your first Pie&AI event, where you are the ambassadors of
Yeah.
Munich
It's a
now.
pleasure.
Congratulations. Yeah, congratulations. And I look forward to a fruitful beginning with BitScrunch. I mean, like
Exactly.
to mark
Yeah.
something
Once again,
new
thank you so
in
much.
my professional journey. I look up to you guys
Sure.
as someone who thrives in with new ideas and new topics. So let's join forces in the coming days. Well, let's talk about it. Yeah, and not to forget Alice
Yeah.
and the team
Exactly.
from Deep Learning.
Looking forward for some.
Yeah, yeah, not to forget about the
Exactly.
team
Thank
Deep
you so much
Learning.ai
for
team.
coordinating this event, Liz.
Hmm. Yeah, and thanks Santosh Balakrishnan. He says Nandri Anna, which means thank you Varun. He says every time you will teach something new. Thanks a lot. Nandini, Vanakkam.
Thank you, boss.
Thanks a lot. Thanks a lot. Thanks a lot, guys. Thanks for tuning in again. Hope to see you all in a different session
Yeah.
sometime soon.